And we're live. Um, all right, so last night while I was working on Buff on Hacked Box, ran into an issue. Wanted to use a interpreter shell, but it kept getting detected by Windows Defender. So yeah, you don't need interpreter shell to beat Buff, but there are going to be situations where I want to use interpreter shell in the wild, just because it makes life a lot easier. So in Privesc, persistence, um, maintain, anything. It just makes life a lot easier. So I would like to be able to run a interpreter shell payload and get it past most antiviruses. So AV evasion. And I found this really cool article last night. I shared it in a couple Discord groups, and this morning I'm going to be walking through it because I think it's really important to know how to do. As because as a system administrator, system engineer, and network engineer, I have put way too much reliance on antivirus. So this has got to be a super critical tool. And reading through the article, granted it is from last year, it's real easy. Granted, it's easy but tedious, like all this stuff. It's easy but tedious. All right, so let's go ahead and pop over into the article. So I went ahead and included the link in the description below. Here it is if you want it. If you can't, if it doesn't work for some reason. But anyway, AV Evasion Part 1. After passing the OCSCP, it fell on top of the world, but soon reality crept in and Windows Defender flagged the majority of what I was taught. Surprise. This gave false sense of securities from Blue Team in thinking that modern antiviruses are pretty good. There's no way its attacker is sneaking past my EDR. I was wrong. It turns out just playing with the payload a little bit completely negates detection, and it lets the red team run free. I want to demonstrate this in this post, the fundamentals of antivirus evasion. So this is the post to learn from, or it's a post I'm going to be learning from. So we'll start with a vanilla interpreter shell payload that gets us the following command. We'll generate a interpreter.exe file in Kali. So I'm going to pop over into Kali, new tab, and then I'm going to go out to revshells.com. And so I am using Buff again as a demonstration machine because I know it has Windows Defender on it, and we already have access. I guess you need to follow me, and I need to trigger the thing. I need to get a hotkey or something. So already have the initial access into the machine. So if I go, who am I? It should return Buff. So Buff/Sean. And this is just a simple web shell, so we don't really have any access outside of this directory. We can read other directories, but that's about it. So like if I dir program data whack, it should return. So there's program data, but that's about it. I'm out of water. Good thing I'm not out of Monster. So anyway, I like rev shells because it's plug and play. So we're gonna go ahead and use 10.10.10.10 for 1433 because that's our VPN address. We're gonna use triple quad force just because we can. We should be, like, if this was a real scenario, we should use port 53, port 80. And a port that's going to be open on a firewall. What? Screw it. We'll just go ahead and do port 53 because I can. And so here's our listener. We actually need a Windows stage. So we are going to have to change. No, I think it was 64. I think it was a 64-bit machine. We can't pull sysinfo from the web shell. There's actually good permissions. All right, so copy, paste. So I pasted that command into Kali, and we're going back to the article. So it wants us to run a full command. So we're not dumping anything in C just yet. And we're going to upload this to antiscan.me. So, actually, I'm going to delete this. See home HTTP and buff, and I'm going to go ahead and remove reverse.exe, and then I'm going to paste my command here. And that'll generate the, it'll generate the payload. Coming back to the article. Now let's upload this to antiscan.me and see how it gets detected. Antiscan.me is used since it doesn't distribute binaries to AV vendors, which makes it more stealthy. So antiscan.me is a website to use. So we're going to go back to Kali. I would bring it into Windows and upload it from there, but the second it hits my Windows machine, Windows Defender flags it, as you would expect. So antiscan.me. Browse, hacked box, buff, reverse, open, scan file. All right, so it's detected by 20 out of 26 antiviruses. It's obviously a Trojan. Wow. I don't know how Panda even flags it as clean. Komodo flags it as clean. WebRoot says it's clean. That's embarrassing. That's really embarrassing. So don't use those. Don't use Panda, WebRoot, Komodo, Clam. Wow. Okay. And in this one, it says, in the article, it says they picked 18 out of 26. It's a fair bit of detection. How do you not detect a vanilla interpreter payload? Which is true. How do you not detect a vanilla interpreter payload? Anyways, modern day malware utilizes 132 API that is built into Windows for several reasons. It is built into Windows functionality, so functionality doesn't have to be rewritten, and it doesn't get flagged by AV. It's usually fast, and it's well documented. All right, so we're doing C# for this documentation, or not documentation, demonstration. As it's easy to work in and well-documented language, such as boot and nim work just as well. This is a standard Win32 API shellcode runner in C# written in Visual Studio. Uses the following function prototypes that we pulled from pwhack invoke. So we need to go pwhack invoke. And where is my Visual Studio? Okay, so what are we needing here? I actually don't know C#, so we're going to learn a little bit here. So this is using system collection, system link, system text, system threading tasks, and I'm an idiot. I don't know anything about C#. I don't remember anything about C#. So let's just copy what he's got written here. So using system.collections.generic, using system.link, I forgot to put the music on. I'm just copying code from the article. So I'm just copying this. I'm just going to write it. So using system.text. Using system.threading.tasks. The important part is it works. Using system.diagnostics. Using system.runtime.interop services. Namespace WIN32. So we need trying to figure this code out. So we need DLL import, virtual allocation, thread, create thread, and wait for a single object. So I think this one's fine. He's in an FL protect. So is it memory protection? No, it's F allocation type, unit F protect. So we need this one. And we need a bracket. Yeah. All right. Class program. All right, so now I need the this is where this goes. Paste. That's the might be the wrong one. So we need DLL import kernel32.dll set last error equals true, exact spelling equals true. I'm just going to use this first one. Alright, DLL import kernel32.dll set last error equals true, exact spelling equals true, hard bracket. Static extern, integer pointer, virtual allocation, integer pointer, h process. Integer pointer, IP address. All right, static extern, integer pointer, virtual allocation, and integer pointer, h process. I don't think we need that. We just need the IP address. After IP address, we need unit downsize. Unit DW size. Unit FL allocation type. Uint. Uint is what it is. So integer IP address, uint, DW size, uint, FL allocation type. Uint, FL protect. FL protect. We can delete that. So DLL import is 1. Alright, so next. DLL import kernel32. So now we need to create thread. Static extern and int pointer. I think that's pointer. I don't know. Let's do static extern int pr virtual alloc. Interesting. Alright, so we need to create thread. think this is it. All right. DLL import kernel32.dll. Get rid of the character set because we don't need it. All right. Static extern and create thread. LP thread attribute unit DW stack size. Integer IOP start address. LP parameter. DW creation flags. LP. All right. Thread ID. I think that's the right one. All right. And the next one is waiting for single object. Waiting for single object. Alright, so this is really just a one-liner. I think this is it. Alright, so 32.dll stat static extern unit 32. Uint 32. Wait for single object integer ptr h handle uint32. Then we'll just get rid of this long. So here's what we got so far. I know I've been all I'm doing is copying out of here and here, trying to get as close as I can. All right, so do we need the pass? We don't need the pass. So static extern, no pass. All right, and I need to write another function underneath that. That's not a function. I have no idea what this is. I think it's just another class or something. I have no idea what I'm programming or what this code does. I'm hoping that it just works because I'm not going to be able to troubleshoot it, interestingly enough. All right, so under DLL import, static void main string args. shellcode here, and size equals buff.length. Int ptr address virtual alloc. I need to get rid of X up here. It's virtual alloc. Oh, there's a space. One, two, three. I think it's 7 Fs. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Yeah, it's 8. I don't know if it's good code, but I don't know. So we're gonna go ahead and save, just because it is what it is. This works. Before we go any further, I'm gonna go use the bathroom. Okay. Alright, so back to the article. We chose C# in this demonstration because alright. So now we will generate Meterpreter C# shellcode and paste where the comment says to. It would have been nice if I could have just downloaded that from GitHub or something, or copied it from GitHub. I'm sure there's something out there I could find. Alright, so back to Cali. Alright, MSVenom, Meterpreter reverse. Let me move this. Interpreter, reverse HTTPS. I'm just going to do TCP. Lhost. Hard code L port. So we just need to change this whole thing to C#. And it says to paste that where the comment says to in VS Code. This code, there it is. All right. So I'm just gonna enter there. I'll paste. So there's our shellcode. And let's compile our code, compile our shellcode, runner, and scan it again. Alright, so I don't know how to compile. VS Code, compile, C# project. Shift Control B. Shift Control B. U command palette. Well, how do you start OmniSharp server? VS Code, start, Omni. Just realized that that music is not good for. I just started. And I was gonna share this on LinkedIn and be like, "Let's check this out." Nope, can't do it now. All right, well. All right. Additional setup for Unity. This is. File. References. Settings. Type OmniSharp. Disable auto start check box. Control Shift P. OmniSharp. Okay. Settings, disable OmniSharp auto start. Alright. I'm gonna save. Make sure to save it. Okay. Close. Open with code. Alright, Control Shift P. Control Shift P. Hate this. This is why I'm not a programmer. Like, I don't even know if the code works. I'm trying to compile it and test it now, but it won't because server, like, it's not run, or something's not running in the IDE. Okay. Output debug console terminal. Executing task, MS build property, generate full pass true. T build console, MS build. MS build is not recognized. That's great. I'm literally on the MS support page now trying to figure this, or documentation, trying to figure this out. Because it should be simple. And at least to me, it's not, because I am an idiot when it comes to programming. Like, I can script. I prefer Python. It'd be great if I could just do this in Python, but... Okay. Let's start with the best matching projects are loaded automatically, but you can also choose projects manually satisfied, blah, 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 blah. Editing evolved. Great. How do I build / run my project basic codes? Builds supports tasks for build and natively understand the output of MS build, CSC, X build. Find out more in the task documentation. Task documentation. Okay. Okay, VS Code can process the output from a task with a... I just want to build. There's gotta be like an easy IDE out there. I'm gonna spend more time figuring out how to compile this than actually like using the exploit. Maybe, maybe. That's not a convoluted way to get there. I don't know what is. Advanced settings. Environmental variables. System variables. What version is this? Let's see, program files, x86, Microsoft. There's MS Build right there. Not even installed in... Why is it installed in app data? $15 gig download to install the tools. Well, I guess this will be continued later once I figure out how to run